Hi, I just wanted to give some feedback on your Module 2 assignments, and I wanted to talk about first the worksheet. So one thing I'm looking for is that you're doing a really good job showing your work. That means that any kinematics equations you use, I need to see them, and I need to see substitutions. In number 1, you were finding the distance and the displacement, and displacement is a vector, so you should have a direction associated with it, like a negative or the word south. And in B, you were finding the speed and the velocity. And since speed is distance over time, you needed to convert your meters per hour to meters per second because those are the standard units that we use in physics. Velocity is the displacement, so over time, and so you're going to convert those meters per hour to meters per second, and it has to have a direction associated with it because it is a vector, so either the word south or negative. In number 2, I was looking to see that you understood that if a car makes one trip around a circle, it has 0 displacement, and therefore its average velocity is 0. Not something less than the speed, not something, not the same as the speed. It can't be because the total change in position is 0 if it ends back where it started, versus the total distance, which would be the circumference of that track divided by time. In number 3, you should, from watching lecture 3.1 and 3.2, where I talked about dot diagrams, you should be able to draw a dot diagram that represents any type of motion. So you would need 7 dots that are equally spaced because it's traveling at a constant speed. And then it comes to a stop, so it loses distance over 3 more dots. In other words, the dots get closer. When you graph that, the position graph is going to be linear for the first 7 seconds because it represents constant velocity. And then it's going to look parabolic during the last 3 seconds. And specifically, the parabola is going to be getting flatter because the speed is decreasing. So you should have a linear line, and then it should round itself off. To find the distance over the first 7 seconds, since it's traveling at a constant speed, it's simply the time times the speed, which is 140 meters. To find the acceleration, now you have information. You know the initial speed is 20 meters per second. You know that it comes to a stop. You know that it does it over 3 seconds. And so you should find an acceleration of negative 6.66 meters per second squared. Some of you did not do the math right, and you ended up with a positive 6.66. This thing is not speeding up over 3 seconds. It's coming to a stop. And then in E, you needed to find the distance that it traveled over those 3 seconds, which was 30 meters, and then add it to the 140 to get 170 meters. In 4 and 5, most of you did these correctly, and these were illustrated and done for you in lecture 5. In number 6, you had a dot diagram, and you were told the car was moving to the right. So if you look at the dots, during the first 7 seconds, they get closer, which means they're slowing down, and then at a constant acceleration. And during the last 3.5 seconds, they are equally spaced, which means they're traveling to the right at a constant velocity. But since the acceleration looks like it speeds up to the right, it's trying to move to the left, the direction of the acceleration is not in the direction of motion of the car. If that were the case, then the dots would be getting bigger to the right. They're not. They're getting bigger to the left. So the direction of acceleration is always in the direction that the dots are getting bigger. So if an object is trying to go in that direction, it'll get faster. But if it's like this example, moving in the opposite direction to the right, it'll get slower. And then you need to sketch the trajectory of the ball. In 7, most of you did this fine. The only problem is some of you only evaluated it from positive 60 meters per second to 0 at the top, and you found the time to be 6 seconds. But that's only half the time. And most of you used your equations correctly. So once again, I need to see what you know, what equation you're going to use, and then I need to see the substitutions and the final answer. In number 8, this thing is being tossed downward. So the initial velocity is negative 20 meters per second, and it falls down 200 meters, so negative 200 meters for y. And a is always going to be negative 9.8 meters per second squared. When you use the equation, you'll need an equation that has time, a, y, and vi in it. So I used y equals vit plus 1/2 at squared. Plugging in the numbers, I got negative 200 equals negative 20t plus negative 4.9t squared. So you can't just solve this for t without using the quadratic equation or graphing it and finding the appropriate x-intercept. And since this is time, a negative x-intercept wouldn't make sense. You would choose the positive x-intercept. So you needed to either use the quadratic equation or explain that you graphed this on your calculator and this was the x-intercept. And then to find the velocity, it starts out at negative 20. It falls negative 200 meters. It's got gravity of negative 9.8, and you're looking for VF. So you would be using VF squared equals VI squared plus 2GY, and you plug your numbers in. And when you take that square root to find VF, you remember square root can be positive or negative. And since this thing is falling and hitting the ground, you would choose the negative square root, negative 65.7 meters per second. Most people did well in number 9. The only thing is in E, they had found the solutions to a previous worksheet, and they made a calculation that didn't even make sense. It had nothing to do with the question. The question asked you to circle the best choice. When you find the instantaneous velocity on the xt graph, you find the slope of the line tangent to that point, because it's changing. And if you find the slope of a line between 2 points, you're finding the average velocity. But you want to find, for instantaneous velocity, you want to find the slope of the line tangent to the point. And in number 10, once again, when you got to E, you guys had some disturbing answers, which indicated that you guys were in fact pulling down old solution sheets, which I had suspected in number 1s because some people had like totally wrong numbers for the time. I change my worksheets every semester, so if you're getting solutions, kudos for you, but make sure that the questions that I have on the current worksheet match the questions on the answers that you're cheating with. I really don't care if you find sources to help you. I really want this to be a learning activity. But if you are not aware that you're answering the right question, then you're just outright cheating and you're not learning from it. So in E of number 10, you only needed to evaluate the displacement from 10 to 16 seconds. So you just needed to find the area under the curve for that part. And so these questions, I'm giving you these questions because you're going to have a final exam. And the final exam is going to have 4 or 5 problems on it that you have to solve in addition to multiple choice. These are the types of problems that you're going to see on your final exam. So I want you to be able to understand how to solve them. Does that mean that, do I live in a bubble and, think that you won't look for answers and, maybe look for old solution sets? That's fine. But you need to be aware I change both my worksheets and my labs each semester. So if you are just looking for answers and just copying and pasting answers in on either of those, and you're not really paying attention to what you're doing, the next time on your worksheet, I'll just give you a 0 for the whole thing. Now, let's talk a little bit about the lab. You looked at balls that were falling, and I changed this lab. I only wanted you to look at one ball. I just wanted you to choose one ball. In the original lab, it had you compare the motion of the styrofoam ball to another ball. So it was obvious that some of you guys just copied and pasted data from some solution somewhere, and you had data for different balls. And I did never at any point did I ask you to do that in this lab. So you need to be really careful what you're doing. Watch the lab videos. I tell you the answers and I tell you how to collect data. Reach out to me if you don't understand. I will help you. I expected to see a position time graph that looked like a parabola. And when you insert that quadratic fit, you need to turn off and unconnect the dots. You should not have this going on. Actually, you should not have a connect the dots thing going on. Okay, there should be no connecting the dots. The only line I should see is a curve fit line. And the coefficient of that quadratic A is always going to be half your gravity. So you should have expected, since these balls were in free fall, that they had an acceleration equal to gravity, negative 9.8. So you had a question, what would you expect the acceleration to be for these balls? The answer is negative 9.8 meters per second squared, gravity. The definition of being in free fall is that they are accelerating at negative 9.8 meters per second squared. That is the acceleration you should expect. You are determining, first of all, if they are accelerating constantly. And second of all, you're going to double the coefficient A in the quadratic, or you'll use the slope of the velocity graph, and that will be your value of gravity using this data, this experimental value. So in this particular example, the value was negative 9.81 meters per second squared. And then you needed to compare those, finding percent error. Now in the graphing lesson, we go over percent error and how to calculate it. And also, you can Google it. You Google everything else. So some of you guys did some weird things with the percent error, and you had a few of you had these same documents that showed the calculation of percent error, which looked like you had got it from some source and it wasn't your original work, because it didn't even use the numbers in your graph. So please be careful. I know you're going to look for things to help you. That's okay, but don't just turn stuff in blindly, because if it's obvious that you have blindly taken answers and you haven't even read the lab, I'm going to give you a 0 on it. I'm going to give you 0 on your homework or your lab if you're cheating and it's blatant. That is just not smart. You guys do not need to be doing that. The only other thing I want to mention to you is to talk to you about the discussion. So in this discussion, it was a 20-point discussion. Every discussion has a rubric listed, so adhere to it. And this one, you needed to make your initial post. That was 5 points. Most of you got that. You needed to reply to 2 classmates, 5 points a person. Okay, so if you only replied to 1, you lost 5 points out of 20. And you need to post on 2 different days. So you couldn't wait to the 7th and post everything, because you're going to lose 5 points. So if you did lose 5 points, it was either because you didn't post on 2 days or that you didn't reply to 2 classmates. And that would be a 15 out of 20, which is an 85. So just be careful with your rubrics, okay? In Module 3, you'll have another worksheet, and you'll have a problem-solving forum. And in that forum, you're going to basically be assigned to a group, and the group is going to be assigned 2 problems to do from a worksheet. And this worksheet contains problems very similar to the ones on your homework. So, for example, Group A is going to do problems 1 and 2, and they'll post their solutions as showing all their work, their equations, their units need to be in meters and seconds, and need to run 3 sig digs. And they're going to post those in their first reply, in their first post. And then you're going to compare your answers to your group mates. Okay, so Now, you're going to have to do all the problems on your homework worksheet, but this allows you to maybe connect with a group of people and start building a study group so that you guys have started working on a couple of the problems together that are similar. And then as you work through the rest of the week, maybe you guys can kind of have a back channel where you get together and you maybe talk and you have somebody to talk to about how to solve problems. Of course, you can always reach out to me and come to office hours, or you can, make an appointment with me. Please contact me via my Google Voice number, via text. I answer it almost immediately. So you'll get 10 points for posting your solutions. You'll get 5 points for comparing your answers to a classmate. And you'll get 5 points for posting on 2 separate days. So just make sure you adhere to that. And I will mention that the solutions to Homework 2 are also posted for you to download. And don't forget that you always have your module reflections, and I do respond to those. So you can go back and look at Module 2 reflections to see what I said to you. And also, you get extra credit if you do them, so do it. You're going to need it on your final exam. Take care.